All right. Hi, everyone. Um, just want to apologize for a late video. I had computer issues today. Finally got a new computer, so I am going to fly through this review only because it's late. So we're not going to be solving every single thing. We're going to use Desmos to show you how to read the answers as well. Okay. All right, so let's start. This is the review for unit 4 test, which is tomorrow. So here we have an exponential function for number 1, which is y equals 2 to the x. So here I have our graph, 2 to the x, which is right here. You're going to plug it in. This is what a function looks like. Now, remember that exponential function, the asymptote, it's actually going to be right here, as close as possible to that line. And again, if you don't know which one line it is, zoom it out. Whichever flat line continues to go straight, that is the one where the asymptote is going to be. For you to recognize it. Now again, exponential function should always have a horizontal asymptote. It looks like this asymptote is in the same place as your x-axis. So it goes through 0 right here, right? Right here. So that means that your asymptote would be at y equals 0. Okay, now I'm going to continue on this graph right here, domain and range. Remember, the domain for exponential function is all real numbers or infinity to infinity, because domain, it's all real numbers, or negative infinity to positive infinity. Why? Because this function moves freely left and right. The only thing that it cannot move freely, it's up and down, because of the asymptote. Asymptote, it's like a brick wall. We can't go through it. So when it comes to range, moving up and down, we cannot move up and down. We can only move from the asymptote up. Okay, that's what a function is in this area. We cannot move past the asymptote. So our range would be the asymptote, which is at 0 to positive infinity. Now, for exponential function, we do not have a closed bracket because the function never reaches the asymptote. So that 0, it's not on the graph. And we are not going to confuse it with the y-intercept. The asymptote is at 0. So that means 0 is not part of the graph. It's just showing the area. That's why we do not include the closed bracket, okay? Now, you have interval of increase or decrease. Well, this function is one or the other. So if you're looking closely, looking left to right. So again, for my students that know, I always start to the left of the graph. And as I go, I have to go up. So I am increasing. What is my increase, decrease? It is, no, there is no decrease. And for increase, okay, I am going infinity to infinity. Okay, because again, I'm coming from somewhere and I'm going somewhere. There is no stopping, okay? There is no decrease. Now, positive and negative numbers, that is represented, where is the graph? If the graph is below x-axis. Now, this graph, if I zoom it out, it is not crossing x-axis, okay? My x-axis is right here, as best as I can do. Oops, sorry. What's happening here? What's happening here? What happened here? Let me. Okay, sorry about that. All right. So, again, this is my x-axis right here. Okay. So my function never crosses x-axis. It's trying to reach it because that's the asymptote. So I do not have any negative values. Everything is above x-axis. So all this function, it's all positive. So again, we had the domain, which was all real numbers. We had range, which was 0 to infinity from an asymptote. We had increase, which was infinity to infinity, negative to positive. And now positive numbers are also infinity to infinity, because again, they moving left to right, okay? So we coming from here and we moving to the right side, okay? And they all positive, okay? All right, so now, last thing that we have, and let me take that here, last thing that we do have, it's going to be end behavior. So that is represented the right side and the left side of the graph. What is happening if we approaching positive infinity or negative infinity? So right here, let me get a different color. Let's get green. This is positive. This is negative. So I'm always going to start with the side where the function is reaching the asymptote, which is this side right here. This side of negative infinity is where my function will try to approach the asymptote. So they are trying to collide together. So that means to me that when x is approaching my negative infinity side, my function is trying to collide and touch with my asymptote, which means my function's approaching 0. Okay? That's what I always start with, where the sandwich is. Now on the other side right here, if I am trying to approach the positive infinity, so when x's are going toward positive numbers, what is my function going? Up. Okay, that's where the end right here is going. It's going up. So that means my function is traveling toward positive infinity, okay? So now let's go back here very quick. I think I need to exit that. All right, so let's go back here. So again, domain, all real numbers, range 0 to infinity, asymptote, it's at y equals 0, increase infinity to infinity, negative to positive. No decrease, no negative numbers, positive numbers, negative infinity to negative infinity. And then end behavior, we said on the negative side, my function was approaching 0, which is the asymptote. And then on the positive side, my function was approaching positive infinity. Now I want you to realize, okay, how the only numbers you see on this screen is the asymptote and infinities, right? Because this is an exponential function, so freely moving left to right, there is a lot of freedom, okay? All right, so I'm gonna clear that, so pause that if you need to. All right, now the second one, oh, nope, that's not what I wanted. I wanted to clear, sorry about that. Okay. Anyway, on the second one right here, let me try to make this bigger. A little bit, okay? Now we have a log function, which is again a inverse of an exponential function. So let's go back to our graphs here. So log function right here, we're going to turn this one off. Now it goes this way, so it gets flipped. Now I want you to realize that when you're zooming it out, you should know that your asymptote is now going to be vertical, because this is the side where the asymptote goes. So here again, we are, let me close this. We are going to have an asymptote. The asymptote is going to go this way. And again, it is a parent function. So my asymptote is at x equals 0. Now remember that inverses of exponential function, log function, it's how the x replaces the y and the y replaces the x position. So in exponential function, the asymptote was y equals 0. In log function, the asymptote is x equals 0, okay? So again, let's go down the list. So domain. Now domain is the opposite. Domain was all real numbers for an exponential function. Now range is going to be all real numbers because I can freely move up and down. I don't have anything stopping me. So that means that range for this function, it's going to be all real numbers or infinity to infinity, okay? Now domain here, it's going to be different. Domain is going to start at the asymptote. And again, domain is x-axis, so it starts at the asymptote and it's moving to the right toward infinity. So domain is going to say 0, where is my asymptote? To the right toward infinity. And once again, open parentheses, because the asymptote is not a part of the function. It tries to reach that 0, but it never ever going to, okay? Now, here, increase, decrease. Again, how do we estimate increase, decrease? We start from the left and go to the right. So again, here, increase, decrease. Guess what? We are increasing, okay? So we are going this way, up. So where are we increasing from? Again, the asymptote to the right. That's the area where we're increasing. So 0 to the right, it's the area where the function is traveling up. So this is increase. And again, increase is from 0 to infinity because we read it left to right, okay? Right, positive and negative numbers. All right, so write that down if you need to, and I'm gonna clear it because I wanna do it fresh, okay? All right, positive and negative numbers. Here it's a little bit different because this is, where did it go? This is my x-axis right here. So again, how do we determine which numbers are positive or negative? What's above that x-axis is considered positive. What's below this x-axis is considered negative. So what determines that? X-intercept. X-intercept seems to be at 1. So that means, again, reading it left to right, 1 to infinity, all the function is above it. So positive numbers are going to be 1 to infinity. Negative numbers, guys, are going to be right here. This is all negative. Okay? But again, rereading it left to right. So we're reading it from the asymptote to 1. In this area right here, in this area, in this piece, between 0 and 1, in this piece right here, that's when the function is below. So again, negative, it's from 0 to 1. Okay? So again, write it down if you need to. And now I'm going to clear it. Now, lastly, we have end behavior. So again, let me write down your asymptote here. Okay, so now again, you're writing down your asymptote. So now, one side goes toward the asymptote and the other side goes toward infinities. So I have two sides here. I got positive infinity and negative infinity. Okay, now on the positive side, I can freely travel and reach that. So that means when x is approaching positive infinity, what happens to the function to reach it? To touch the function, I have to travel up. Okay? Now, what happens on the other hand when I'm trying to reach negative infinity? I'm not able to get to negative infinity, unfortunately. If I want to travel toward negative infinity, I'm going to get stuck at the wall. So I cannot say x approaches negative infinity. But what I can say is x is approaching the asymptote, which is 0. When it reaches the 0, what happens? Where is the straight line going down? Okay, so that means negative infinity. All right, so when I approach 0, I got to go down toward negative infinity. All right, so now let's write it all down in one place, okay? All right, guys. So again, domain was your asymptote, which was 0 to infinity. And the range was all real numbers, or infinity to infinity. Asymptote was vertical at x equals 0, not y equals 0. Increase, no decrease. Increase was from an asymptote to infinity, so from left to the right. Positive numbers were from the x-intercept, which was 1 to infinity. So 1 to the right, remember that, okay? It was from here this way, right, when the function was positive. And then negative numbers were between the asymptote, which was 0, and that 1, okay? End behavior, when we had the asymptote here, remember that on the right side, I was able to travel to infinity. And when I did, I had to go up to reach my function. And on the left side, I couldn't go toward negative infinity, but I went toward the 0. And when I reached that 0, I went down toward negative infinity to travel where the function was, okay? All right, pause that if you need to. All right, next one. All right, we got another exponential function, but now it's a little bit moved. So we can talk about transformations. So let me make this bigger very quick for you. So once again, what are the transformations, how the function moves? So remember that a parent function was 2 to the x. So anything that is any other number like -3 and 1 is going to move the function. So 1 on the outside moves the function up 1. And then the -3 on the top with the exponent will move it oppositely. And instead of going 3 to the left, we're going to go 3 right. Okay? So now, domain and range. Let's see up here what the function looks like. So let's turn this one off and turn this one on. All right, so the function is a little bit moved. My asymptote right now looks more like it's approaching 1 here. Okay, so like if you look at right here, y value right here, it's 1, getting closer to 1. So it's going to continue to be getting closer to 1 forever and ever and ever, and it will never reach it, okay? It's that second number. So that means that my function is trying to approach 1. And again, I'm gonna try to do my best to draw it as close as possible. So that's my asymptote, okay? So the next thing we have, so the asymptote is at y equals 1. All right, next thing on the list is domain and range. So again, remember the domain for exponential function. It's all real numbers, okay, or infinity to infinity. Range, on the other hand, which is up and down, it's going to go from your asymptote up, because that's the area the function is in. So you got 0 toward infinity. No closed brackets for neither log or exponential function. Next thing on the list is the function increasing or decreasing. The function's increasing coming from the left here, okay, going all the way to the right and up. So again, increase, and it is increasing infinity to infinity, because again, how do we read functions? Oh, please don't do that. Okay, sorry about that, y'all. I'm gonna have to exit again. Sorry about that. And again, it's increasing from infinity to infinity. We're having some difficulties. So again, let's write it again. Asymptote. Okay, so increase, negative infinity to positive infinity. Because why? Because we're coming from here and we're going there, okay? So in this area, it's increasing and decreasing. The next thing on the list is positive or negative numbers. Now, once again, what I am paying attention to here is your x-intercept, and the whole entire function is above it. So the whole entire function is positive, okay? So positive, and again, negative infinity to positive infinity. Reading it left to right, okay? And then lastly, we have end behavior. All right, so again, one side of the function is going to be approaching the asymptote, looking like a sandwich, and the other side of the function is going to be going in its own way. So right here, it's a sandwich. Which side is that? Negative side. So I can truly say that if I am trying to approach the negative infinity side, where is my function going? Toward the asymptote. Which is 1. Okay, I am traveling toward asymptote. Now, on the other hand, if I am trying to go toward positive infinity here, to reach my function, where do I have to go? Up. So, positive infinity, okay, if I am approaching positive infinity, my f of x, it's going to go up. Okay? So let's write that down clearly. And our notes right here. So again, here, transformations we already talked about. Domain was all real numbers. Range was from your asymptote, which was 1 up to positive infinity. Open parentheses. Asymptote was at y equals 1. Increase, no decrease, was infinity to infinity. Because again, it's an exponential function, it moves freely. Positive were all of them. So again, negative infinity to positive infinity, no negatives. And end behavior, one side, the negative side was going toward the asymptote. Okay? And then the positive side was traveling up. Okay? All right, log function. Okay, again, we're going to talk about transformations. This function is moved. All right, it's moved down. This is your x-axis right here. So this function is below a little bit. Of course, my asymptote is going to be on this side right here. So let's talk about transformations. So here I moved down 1 and I moved left 3, the opposite. Okay. Now remember that for the log function, range, it's all real numbers, infinity to infinity, okay? Because again, it moves freely up and down. Now let's talk about where is our asymptote. Asymptote looks like it's right here at -3. So let's write that line. Now again, that asymptote at -3 is going to be very important. So domain is going to depend on this -3. Domain is going to be this -3 toward infinity. Okay. So we got domain -3 to infinity. Okay. We talked about range already. It's all real numbers. We have increase, decrease. This function is obviously increasing, and once again, it's increasing from the same asymptote to infinity. Okay, so increase. It's going to be the same, -3 to infinity. And again, I am really sorry for the technical difficulties. Okay, no decrease, positive and negative. Okay, so positive and negative, so write it down if you need to. Let's go back here very quick. So again, domain was -3 to infinity. And asymptote was at x equals -3. No decrease, increase was from -3 to infinity, okay? Now, positive and negative numbers are going to be a little bit different because some of the function, part of the function is on the bottom, some of it's on top. So positive and negative numbers are going to depend on x-intercept. So make it smaller right here. So where is the x-intercept? It's right here at 7. So that means that at 7, guys, part of the function's above and part of the function's below. 7. Okay? So all of this is above, which means 7 to infinity, it's positive. Okay? Between asymptote and 7, it's all below x-axis. So all of this part of the function is below. All of this. So between these -3 and this 7 right here, the function is below here. So negative is going to be from -3 to 7. All right, so let's write that down here. Negative numbers from the asymptote to the x-intercept, positive from 7 to the right of the infinity, okay? And then lastly, we have an end behavior. Again, one side is going to go toward the asymptote, and one side is going to go toward infinity, okay? So right here, it's my asymptote. So that's the negative side. So I'm going to say as I am traveling toward my asymptote, so as I'm going this way, that means I'm going to travel down, okay? So as x is approaching my asymptote, which is at -3, let me write it here. As x is approaching my asymptote, when I reach that asymptote right here, guys, as I'm reaching that asymptote, my function travels down, okay? So f of x is going to -infinity, all right? Now, on the other hand, when I'm traveling toward positive infinity to the right, on this side, I'm going to have to go up. My function travels up, okay? So on the positive side, I can't travel toward positive infinity. My function then has to travel up, okay? So again, pause that if you have to, and make sure that you write that down. All right, and then lastly right here, we have a radical function. That's my dog, y'all. Sorry about that. All right, radical function. So once again, let's graph it. Radical function is a little bit different. It will have closed brackets because the radical function stops at the point. And it stops at this end point right here. This point is 3, 2. That's very important. Also, this point is very important. 3, 2, it's important. And your x-intercept is important. Okay? So let me actually, I can even graph it right here for you. All right. So first of all, transformations. 2 on the outside means 2 up, shift. -3 on the inside means the opposite, 3 right. Okay. So we have 3, 2. And it goes through 7. Okay. I want to acknowledge that. So just a little sketch. Okay. This point 3, 2 is very important because the 3 represents domain and the 2 represents range. Okay. So domain. Domain means this is domain, this is x-axis, domain. That means that from that dot, I have to go to the right side, okay, to reach toward infinity. So that's the area where the function is. 3 to infinity is how we read our domain, left to right. So 3 to infinity. Now, very important, 3 does belong to the graph. The dot, it's on the graph. It's a part of it, like your jacket or your shoes, okay? Now, for range, I would think, if I'm talking about range, I would say 2 down, right? That is correct. We would say 3 to -infinity, but the way that we read it is -infinity to 2. Sorry, -infinity to 2. Okay, because range it's 2. So we are going to stop at 2, but we're coming from -infinity. Okay, so again, range. I know you guys want to say 2 to -infinity because this is what you see, but you always read the function from the bottom to the top. So we are going to say we're coming from the negative numbers and we're stopping at 2. And once again, closed bracket because it represents that the point belongs, okay? Increase or decrease, this function is obviously decreasing. It is going down. So we are going to have a decrease, Okay, and then again, how do we determine the decrease? We read everything else other than range, left to right. So our decrease is 3 to infinity. Okay, that's the area where the function is coming down. So 3 to infinity. Okay, positive, negative numbers. Now, that's very important because what's going to determine that is that x-intercept at 7 right here. So this right here is very important. This number 7, because x-axis, what's below? This piece that's right here, it's all negative. So how are we going to determine it? From 7 to the right, 7 to positive infinity, not 7 going down, because that's where the arrow is taking you. We are reading function left to right. So once again, 7 to infinity, in this area, my function is negative. So 7 to infinity, it is negative. Now, where is the function positive? Right here, guys. That's all positive. So what are the points in between that's positive? 3 and 7. So it's basically from where the point starts for x-axis to the x-intercept, okay? So 3 to 7 in this area, the function is above x-axis, so that's positive. So 3 to 7, okay? All right. Now, end behavior, let me rewrite this again. End behavior, it's right and left. So here you got this function. This is 3, 2, and the function is crossing. Okay. So how do we determine end behavior? Right or left? So on the right side, I have freely to go. So right side is always positive infinity. So that means if I am trying to go toward positive numbers, where's my function traveling when I'm on the right side? Okay. My function will travel down to reach it, toward negative infinity. So that means when I'm traveling with my x's are getting larger. My function is traveling down to a negative y's, okay? So f of x is traveling toward negative infinity, okay? Now, what happens to the right side? Can I go toward negative infinity? No. When you looking at the right side, you are going toward the point. So what happens really? Okay? Well, if the x's are trying to reach 3, because that's the x, the y's, the function is trying to reach 2. So remember that for radical function, when you're trying to go to the x's of 3, the function is trying to reach your 2 for y. Okay, so whatever represents x and a y will represents x and a y here, okay? All right. Now pause that if you need to. All right. Now, all of these could be simply plugged in into Desmos. I'm going to show you one of them. Okay, very quick. All right, so once again, I am going to show you just one time. So let me show you the first one, number 6. To get that extra log, you can go to a function, log a. So you're going to plug in 16 on the bottom and 32 up here. Oops. And 32 inside. Okay. And it's going to give you 1.25. I will show you one more. Let's just try number 7. So again, you can go to functions. You're going to go to log 7. On the inside, you are going to have a fraction. So that's 1 divided by 49. Okay. Now let me show you one more. How do you do, for example, 11? You're going to say 3 raised to. Now you're going to go to log again. You have to plug in and make sure you do that because you want to have a log base. You're going to do log base 3 and then off 32. And you get 32. And then let me show you one more, which is your number 13. Again, you can do function log right here. So you got a log 2. Now you're going to do 1 over 8. Okay. Then you close the parentheses plus, and then you have another log. Okay. And you got a log 7 of 300 on the inside, 343, okay? And you get a 0. So let me just give you the answers. So try them out by yourself. But the first one right here should be 1.25. Number 7 should be -2. Number 8 is 0. You get a 3 here. You get a 3 here. And again, let me show you the ln just so you know. Again, how do we find an ln? It's also, you can write ln or you can just find it in here in the same place. ln right here. Now, you're going to do ln of e cubed, okay? And you get a 3, all right? So this one was 3, this log was 32, this log was 4, and this log was 0, okay? All right, next question. All right, so use the graph to answer for the following question. Which of the following statements are true about the graph and exponential functions? Select all that apply. You have a lot of multiple answers here. I purposely wrote this as this point is 0, -3, just so you can see in case it was hard to see. All right. First question says the y-intercept is 0. No, the y-intercept is at -3. 0, it's an x value, okay? So that is not a true statement, all right? The asymptote is at -4. Remember, this is an exponential function, so asymptote it's right here, as close as possible, and it does look like it's at -4, and it is y equals -4. So this is a correct statement, all right? Now, C. C has been one of the most missed questions by students because students rely C to increase and decrease of the function, and that is not what it talks about. This is as x increases, f of x approaches but never reaches -4. This means as x is approaching positive infinity, as x is getting larger, going in this direction, as x is increasing, that means going toward positive. My function is trying to approach asymptote. That is a correct statement, okay? So this is basically saying as x is approaching positive infinity, f of x is trying to approach my asymptote. That is a correct statement, okay? It has nothing to do with increase, decrease. D, the x-intercept is at -2. X-intercept will be right here, and it is at -2, so this is also a correct statement. All right. Next one, okay, is the domain is all real numbers. That's also a correct statement because remember the domain is always all real numbers for exponential function, so the function can move freely left to right. F of x is positive over the interval of -2 and infinity. All right, let's check that. So let's delete some of that stuff here so we can clear it. All right, so positive and negative, let's see. So again, x-axis is right here. So that means this is my x-intercept at -2. That means this is positive above x-axis, and this is negative below x-axis. So I'm reading it, so this 2, -2, it's my point where it switches. So this is saying -2 to infinity. So from this point to here, it is saying that my function is above here. It's not, it's below. These are negative values, so this is not a true statement. My function is positive from -infinity to -2, but not from -2 to infinity, okay? So this is not true. And then lastly, G is correct because -4 is where my asymptote is. And once again, let me delete all that. I am saying that my range means area, right? I am going from my asymptote, where is my function? Is it below here? No, it is above. So I am going from -4 to infinity with open bracket. This is also a correct statement. So B, C, D, E, and G are all correct. Pause it if you need to. Question 15, okay? It's saying, which of the following statement is true? Reading the function. Okay, so again, this is a log function. So my asymptote is going to be placed vertically, okay? Let me write that better. And it does look like the asymptote is at 4, all right? So that's very important because I can automatically eliminate answers. First of all, remember the log functions. One side goes toward the asymptote and then up or down, and another side goes toward infinities. So as you notice, the beginning up here all goes toward the asymptote other than this one. Now, can I, since my asymptote is on the left side, going toward left side, I have to go toward that asymptote. So that means I cannot go toward infinity, negative, because I can't get there, okay? I can also not go toward -1 because my asymptote is at 4. But I can go toward infinities, okay? I mean, toward 4. So when I go toward 4, right here, what happens to my function? It goes down. It checks out for both, okay? So now I am eliminating this to an A and B answer. Now, let's see what happens to the right side. Okay, so I know that on the left side, I am going toward the brick wall, toward the asymptote right here, right? All right. Now, what happens when I go toward positive infinity? Because this is negative, right? And I cannot reach it. All I can get to is that asymptote, okay? Now, what happens when I go to the right side, toward positive infinity? Where's my function going? My function is traveling up, right? Right here. So that means if I'm going toward positive, I got to go up. So my correct answer is going to be B, not A. Okay? Again, pause that if you need to. All right. And number 16, which of the following statement is true about this graph? Now, this is again a radical function. So this is a very important point at -3 and 2. That -3 and 2 is going to determine your domain and range and all kinds of stuff, okay? So, first question, as x values approach positive and infinity, f of x is approaching negative infinity. Again, that question is the end behavior. All it is saying is that if the x's are going toward positive infinity, means if the x's are going this way, the function, this is f of x, this is your y, your function is approaching negative infinity, mean going down. That is a true statement, okay? Now, the function is increasing on the interval of -3 and positive infinity. Right there, I'm going to stop and say, is this function increasing? It's the first question. No, it is traveling down. So this is not a true statement. So right there, I'm not even going to bother trying to figure out the values because I know this function is decreasing, okay? D, f of x is negative for all the values that are greater than 1. So first thing I'm going to do is I'm going to find the x-intercept, which is here, which is at 1. Now I'm going to find negative numbers, which is below x-axis, which is 1 right here, okay? Now, this is saying that the negative values are for all values that are greater than 1, so more than 1. So I am 1 here. What is more than 1? Right here. Okay, is that true? Yes. Between 1 and infinity, all the numbers are more than 1. The values are below x-axis. They are negative. So that's also true. Okay. Okay. Now, range. This one has a bracket. Okay, so let's check it out. First, bracket sounds like it could be true. So that's a plus. Now, we saying negative infinity to 2. So first, remember, x is domain, y is range. 2 checks out with range. Now it's saying negative infinity to 2. Very good. That is also a true statement. Negative infinity, we're reading it from bottom up, to 2 on the y value. It's a correct statement, okay? F. As x values approach positive infinity, f of x is approaching positive infinity. Now, we already had this question here as A, as x values positive infinity, then we said that was true, so this automatically could not be true. If I go toward positive infinity, my function is not going up, it's going down, okay? And then lastly, it's saying as x values approach negative infinity, so we now going to the left, f of x is approaching 2. So remember that one side for radical functions goes toward infinity, and another side, whichever side that's going to be on, is going to go toward your point. So can I get to negative infinity? No. I can only get to that point right here. So I am approaching -3, and while I approach -3, my function is approaching 2. So a statement as x(y) is approaching negative infinity, it's not true. I can't get to negative infinity. I stop right here at -3. That's why my function has their dot, okay? So no, that is not the correct statement. Pause that if you need to. All right, and lastly, I'm gonna go over extraneous solutions. So question 17. So remember, again, this is an abbreviated version. How do I find extraneous solutions? You can solve it by squaring both sides. All right, so again, you can square both sides. The 2 will cancel the radical. You're going to get 4x plus 4. And here you're going to get a quadratic equation by doing a box method of multiplying x minus 2 twice. When you get that, you are going to get x squared. You are going to get negative 4 x and then plus 4, okay? You're going to move everything to one side, find your factors, and then plug them back in to see which one does not work. Now, due to the fact that the video is recording so late, I'm going to show you how to do it on Desmos. So to be able to do it on Desmos, you're going to plug in the original function, which is your, let me see if I can move this, okay, which is your square root of 4x plus 4 equals x minus 2. That is your original function. Now this 8, it's not an extraneous solution. This is a solution. Now the other point that did not work, that did not make the function true, you are going to copy this function, you're going to plug this function in, and you're going to put squares around it to be able to view the other function. Okay? Which is 0. Now I want you to see, it's only showing you a solution. When I plug it in, it's showing you both points. 0 is the one that would not work. Now you can plug in, so again, if you look back here, you will know that the answers were 8 and 0. And you can plug them back into the original equation and say, okay, 4 times 0 plus 4 square root equals 0 minus 2. So this is going to be 4 times 0 is 0 plus 4, it's 4. Square root of 4, it's 2, does not equal negative 2. That's why it's not true. Left does not equal the right, okay? So your extraneous solution is 0. That should be your answer for this question, okay?